My name is Ixchel Ruiz, and I didn't add a lot because I usually don't like to talk about me, but we were in the Women in Tech breakfast, and that reminded me that I should say some of the stuff that I have done. So I'm a Java champion and a CDF ambassador. I'm an open source advocate. I have written some books. And what else? I help organize different conferences around the world and on conferences. And I have an amazing team. I work with an amazing team of people, and she's actually my colleague and my dear friend.
Thank you very much. I've known Ixchel for years. She's very community-minded and definitely brought me up into the community. Goodness, maybe 10 years ago now. Let's not talk time. Too much time
You
has
should
passed.
ask Dave.
We'll age ourselves here. My name is Melissa McKay. I am also a developer advocate with JFrog. I always like to say I was a developer first, though. This is my third year being an advocate. It's a very different type of position than what I came from. I was a developer all the way from lowly intern to principal engineer, and then I really found a passion for the community, really enjoyed starting to do public speaking, and wanted to find a way to do that full time. So here I am. I'm also a Java champion, also involved with the CD Foundation. I am a co-chair of the special interest group called Interoperability, and I'll talk a little bit more about that later. And one interesting thing about me is I adore the game Pokemon Go, so you'll see me often wandering the streets playing that game, catching them all.
The last project that we had together, we wrote this book with other two people, Stephen Chin and Baruch Sandarsky, so DevOps tools for Java developers. So if you're interested in that, please go to O'Reilly and get a copy.
Yes, this was an interesting project to work on because it really made us very aware of all the things that you may not know when you're first starting to go into this field, especially as a Java developer specifically, yes. And especially before this whole culture change of into DevOps, so that you no longer have developers that are by themselves in silos throwing things over the wall to operations. So really interesting, fun project. Learned a lot doing this. They always say, when you teach somebody something, you learn it especially well, and I feel like we did that writing this book.
So what we're going to do today is we were going to talk about our experiences and some of our clients, because we were consultants or work for companies, about what are the challenges when you are building initially your CI/CD setup.
Yes, we'll get into all that entails, as well as developer versus DevOps. That's an ongoing debate. And we'll talk about a lot of the why. That's my biggest and most important word in my life is why. Why do we do this anyway? Not used to just being told what to do without understanding the reason for it. So we'll get into that.
And if we are doing it, how do we measure success? How do we know that we are crossing the line? And the other thing is, we're going to talk about the best practices. We want you to take something very actionable from our session. And we're also going to talk about why DevOps is not happening just yet.
Yes.
And some of resources that we think that are really interesting for you to look at. So, Melissa, how do we start with our CI/CD pipeline?
Yeah, so this can be pretty overwhelming because when you stop and think about it, there is a ton involved in just getting a software project up and running to start with. A lot of us kind of, we might move into a team or move into an organization that has a lot of this already in place. But if you were to start from scratch, there's a ton that you need to think about. And it starts all the way back to the planning stages, getting your developers' machines, making sure that everyone, is in line with using their IDEs, Mac versus Windows. I remember the first time I was given a Mac versus a Windows machine because that was all I knew, and how terrified I was about that. So luckily at that time I had a very good team and we were all able to learn from each other. Code, learning, figuring out which language you're going to use. That's a whole process. Sometimes it just has to do with the skill sets you have available to you. Other times it's very project specific. Some languages are just better served in some areas than others. Source control, of course. Who all uses GitHub in here or some form of Git? Awesome. Anyone use Perforce?
We're trying to feel.
Okay, so for a lot of my early career, I was using SVN, Subversion. I just remember the pain of moving to Git, how different that was, but how much better our lives were after doing that, just because of some of the process changes that happened at the same time involving like PR requests and things like that. Build servers. I think both you and I, Ixchel, we have a lot of experience with that just over the various teams that we've worked on. All kinds of servers out there, Jenkins, Circle CI, Bamboo. There are lots of choices, and they all have their pros and cons. Security scanning. Got to consider that now. This is the year for security concerns, I suppose.
The last 2 years.
Yes.
Like, we have made the news. Who doesn't remember Log4j? And we literally stopped the world. Java went into the front lines. Yep. Everybody knew us. Yes. And not in the good way.
Right. I think as developers are all becoming very much aware of where we fit into that as well, and how much power we have at the very beginning of the life cycle, the things that we can do now that are available to us to help prevent these issues. Obviously, we're not going to fix everything, but there's a lot that can be done to help protect ourselves and our organizations a little bit better. Artifact management.
That's a topic dear to our hearts. And we don't have to explain to you that we are going to propose Artifactory, but that's true.
Right. You can't, well, there's this phrase, you can't secure what you don't own. And I think that's a really good position to have, a perspective to have. Maybe, regardless of what system you use, it's good that for your software builds, you have control over your dependencies and your resources. This way, you're never relying on someone else in another organization with other priorities to be managing your releases, your immutable objects that you trust are going to be around when you need them.
Because sometimes archiving algorithms change, and that could be surprising. If you did you know about GitHub changing their archive, the way they were constructing the torvals? They changed it. It probably you didn't notice because they rolled back the change in 4 or 5 hours. Yeah. But still, at that point, it impacted a lot of projects that were actually building from sources. Yep. And requesting the tar files. You can look at it. It caused quite the chaos for 5 hours, like 2 weeks ago? No, 1 week ago.
Yeah, it wasn't that long ago.
Yes.
It was like last week. Yeah, very interesting. It's an interesting problem to have because, one organization has priorities that they have every right to make changes, but there's a lot of assumptions about dependencies there that the community assumed things were immutable that were not. So important just to know where you stand, especially in your individual projects. Cloud resources. So many of us are working on projects that are cloud native. So obviously you're going to have all of these discussions. Where do you want to be? Which cloud provider might you be utilizing? One of them or all of them? There's a lot to unpack there. Deployment infrastructure. So this is a whole nother thing. I remember being on a team once where there just wasn't a lot of effort or motivation to set up staging environments or testing environments. Well, we felt that pain very much because it was literally testing in production, not really a good way to go. Thankfully, this wasn't, a high risk project, but we learned a lot and we learned how to make sure that our testing environments at least were as close to production as possible. And also dealing with data. You're going to have to learn or figure out, what databases you might need, especially if you have a data-driven app. These are all going to be differences you're going to need to come up with, whether you're using NoSQL or relational databases, things like that, as well as message brokers or caching mechanisms like Redis. Automation.
Yes, I mean, at this point, we should have really well-defined processes separated by automated tasks and repeatable steps. And these shouldn't be part of our daily jobs, or at least our daily concerns.
Right. And then lastly, but certainly not least, observability tools. This is something for a long time in my career as a developer I wasn't really involved in. It was so far at the end of the life cycle that I didn't really pay attention to it. Now this is different. Now being on a DevOps team, it's very important to get these measurements, to get real feedback from your production environments in order to feed that information back into the beginning of your cycle and begin bug fixes or new features, things like that.
This is the only place where I said we do test in production, but we are getting information from production about how our system is behaving. So this is a very valuable part of our whole development cycle.
Yeah, just examples like Datadog, Sysdig, using Splunk to get all of your logs together, all of that very important stuff.
We did remove that one. And if you're starting, like for example, going with microservices, cloud native, or even having an idea of all this, you land in the CNCF. This is the CNCF landscape, and it looks impressive.
It's overwhelming. There's a ton of stuff here. Just in this little section here, it's under scheduling and orchestration, there's 20 items that are categorized under here. 7 for coordination and service discovery, 10 for remote procedure calls, 21 for service proxies. These are things like Nginx, 19 of them under API gateway, and 17 under service mesh, which I thought was pretty incredible. I remember looking at service mesh a long time ago, and I think there was just a few big ones on the scene at the time. Now there's 17. So this space is growing like crazy.
Yes, we have the QR codes of most of our resources, so don't worry. If you are watching this video later on, you can get all the references. So, impressive, isn't it, Melissa?
Yes.
So impressive that you can make a puzzle out of it.
This is a meme that went around for a while. I love this 1,000-piece puzzle, and the fact that there were 42 sales and it's sold out. I think that's interesting. But yeah, just the joke that there's so much involved here and so much to choose from.
And
now, go ahead.
No.
They do their best to give you a map. We need some help deciding what to start with. These decisions can be overwhelming, so there is some work done here.
The trail map. So that's exactly what we want to do here today. You will see a lot of best practices, products, and things that can help you in your DevOps adventure. But we want to give you some ideas of where to start for you not to have the same problem as the CNCF, the landscape, and being so difficult.
So all of these can be brought down into a more simpler view. These are what we called core lifecycle pillars that developers and DevOps teams would be concerned with. First, your source code repository, setting up your continuous integration. A lot of these things we might take for granted now, but remember, there are always new folks coming in from school, just graduating. They may not have had a lot of experience with these tools in the beginning, so it's important for us to mentor and remind best practices when these things come about. Package managers, the ability to collect all of your dependencies and also to publish your artifacts as needed. Security scanning, this is not just a tool that's in a certain specific place in your pipeline. It's actually something that needs to be considered from the beginning. So there's even tools on the developer side where you can begin this scanning process
As soon as possible.
As soon as possible, so that you know right away if you're going to be introducing more issues or fixing some issues. And then continuous delivery and deployment, making sure that you have the appropriate automation in place in order to consistently deliver and deploy your applications, not just to production, but also to staging and test in the stages in between as well. And then we can't forget the observability tools.
I mean, I cannot stress like hard enough how important is this, and because in the past, well, we had more or less, in certain degrees, this. Maybe we were releasing manually. We didn't have the automation tools. We didn't have the package managers to create our own, like for example, homebrew formulas or Docker images. So we may have been doing it a little bit painful. But the new kid on the block, it's observability. And this was born, this is super necessary if you have adopted the microservices architecture pattern. But my point is the lessons that we learned and the tools that we're using there that were really easy to use, most of the cases, and really easy to add into our existing projects are super valuable. So I urge you to have a look on all those tools. So in the agenda, we talked about and when we were writing the book, there was a lot of people that were saying, well, DevOps doesn't exist. DevOps engineers are very new into our story, and they don't know what they're doing, or they are actually not developers. They are only from operations teams. And there was kind of a conflict there between developers and DevOps.
Yes. I think there's a disconnect on what DevOps actually is. It's more of a methodology, a way of doing things, a set of processes. I would never expect in a DevOps team that one member of the team knows everything. And this is one of the sensitive points for developers, I guess. We need to remind ourselves that the whole idea of having this team and having the different expertise on the team is that we utilize that with each other. It's too much to ask one human being to know everything. Now, obviously, as you grow in your career and you start adding more things to your toolbox, you're going to be in a more confident space, knowing more about the other positions on the team. But when you're first starting out and when you're assembling a team, it's best that you utilize each other's expertise.
And if you want to read about the beginnings of DevOps, there is a book, The Phoenix Project. It's a novel, and it's going to tell you the story how all these concepts began from the management perspective. And then years later came up another book, another novel, now telling the story from the developer's point of view. So this is super interesting. If you ever are curious, I totally recommend you both of those books.
Now, there might be another reason that developers should care.
Yes. I mean, when I present part of this presentation to young students, I show them this. And for example, in Germany, the average salary for a DevOps engineer is 58k euros. And for the software engineer is 54. And that also happens in the US. The average for a DevOps engineer is 98. And the average for a software engineer, 88. I'm happy to report that here in Sweden, the story is different. But not as you will think. The average salary of a DevOps engineer is 490, and it's the same for a software engineer. But the trend in other countries, and that also happens in Mexico, in Switzerland, and other places where I have shown this kind of graphics, is that the DevOps engineer are slightly better paid than the software developer. That's interesting. But actually, that's not why you should be caring about DevOps. That was just like a commercial. So why do we care about? Why should we care about DevOps?
Yes. So we all want our projects to be efficient. We want our teams to be able to work together and to be able to get our products and services out there as quickly as possible and as efficiently as possible. They also need to be reliable. We aren't very successful when we have services go out and they are down all the time. So And then economical too. I put this picture of my car. Yes, this is my car. This is what I drive at home. And as you can see, there's a little wound on the side. I got into a little fender bender. And but for the purposes of this car, it gets me to where I want to go. And when I look back and look at the price of fixing this car compared to getting a magnetic Band-Aid from Amazon for $12, that's what I chose to do. And sometimes this is the state we're in with our projects, because a lot of the motivation behind the decisions made does have to do with economy, with how much it's going to cost, not just in money, but in time. So making these decisions on how worthwhile it is, these are all to be addressed. When you're looking at your life cycle, it's very important, each stage, try to find those bottlenecks and make a point to make improvements everywhere you can. This means automate where it makes sense. This means if you have a particular bottleneck, for example, deploying to your test environment because it's not consistent with your production environment. These are all things where you can improve. And by improve, I mean don't bite off the whole thing and try to get everything perfect. It never will be. This will be continuous improvement. So focus on the highest priority item and improve by 1%. When you've measured that and you've met that improvement, now it's time to look for the next bottleneck so that you can continue and proceed to improve.
Yes, big band efforts I haven't seen them work quite as people that thought it was going to happen. So start slow, and remember, this is a continuous process. Even our own setup, our own infrastructure has to be reviewed every single time, and we need to know if we are going or we are being successful. So actually, that's the next question. How do we measure success in our applications? So there are 4 metrics. These are the four key metrics of software performance. So we have the lead time for changes. This is how much time do we have or do we spend from the time that we finish a feature and it is deployed on the wild. The medium time to recovery. So from the time that we find an issue in our code or in our services running to we remediate, and we had quite a nice discussion, because I'm not saying fixing. I'm saying remediation of the problem. How much does that take you? And our deployments frequency. The deployment frequency refers to how fast you can do a deployment, not how fast you need to do a deployment, because there are industries where once every 6 months, one every year is more than enough, or they are restricted by regulations. But the fact that they could do it every single day or every hour is what we are aiming here. And the change of failure rate. How many failures or issues are we deploying into the wild? So these are the metrics. These are metrics, well, it's well known in the industry, but actually the measurement is coming from the DORA report. And this is a DORA report from last year talking about the different industries and how they have applied DevOps practices inside of their process. So what is the important part of this? The first 2 ones, the lead time for changes and deployment frequency, will increase the throughput of your application. And the 2 last will show you how stable it is, your software development chain. And one of the most interesting things about this particular report is actually segmented in 3 different categories. Industries that have low adoptions, they are still starting their adventure in DevOps. The middle ones that declare that they are almost there in the process, maybe they have some teams that are doing great, maybe they don't. Not all their teams are up and running into the DevOps adventure, and the really good companies, think Netflix, think Airbnb, with A/B testing. Does anybody here has heard about A/B testing? Great hands. So Airbnb actually was the place where it started, and they do tons of deployments per hour. Well, anyway, so for the application, for the companies that are low in the adoption of DevOps, the lead time for changes, it could be once every month, once every 6 months. For the mid adoption is one every week to one per month. And the ones that are living the life, they can do it whenever they want. The deployment frequency, as you can see, is also between 1 month and 6 months, 1 week and 1 month, and 1 day and 1 week. And what I actually like it more is the change failure rate. The amount of failures that we are seeing in the wild on the industries that are improving, or that they are the elite on the DevOps adoption, is very, very low. And this is one of the reasons why management is so keen in us to implement DevOps practices. Because if you transform this into money, the advantages when the managers or the CEOs or the CTOs see this, it's in the thousands. And sometimes it's in the thousands per day. So they are like, of course you're doing DevOps and you're doing it yesterday.
There's one thing about that
yes.
I'd love to discuss, because this is something that comes up often when I have discussions about this. This idea, like, for example, if you were to focus on just one of these, deployment frequency, and let's say you have a team that says, okay, we're going to make sure our deployment frequency is a lot. And then the end result at the end of the day is, yes, we deploy a lot, but we have a lot of bugs. It's always down now because we don't have the systems in place to make sure that our deployments are actually reliable. So you can't just take one of these items and only focus on it. These all are interrelated and depend on each other. In order for everything to work, you really need to focus on mitigating other risks. For example, deployment frequency, this whole idea of blue-green testing. Being able to mitigate your deployment so that you don't bring a whole system down, irretrievably without, proper testing in place.
And this is what we were talking about, remediation of the failure. It's not that we are going to fix the bug in this particular service, in this particular version. What we have all the infrastructure to do a rollback. So that is remediating a failure. That's not fixing the failure. So we actually have to have all these plans. I mean, things are going to go wrong. We know. I mean, that's something. Failure is not an option. It's a fact. So we need to know how to fail and fail gracefully. So this is also something that you should have as part of your process. How are we going to react? Do we even know how to react? How fast can we react? What are the steps? Who is involved? What is the change of communication? What are the expectations? How do we act flexible? And if we are going down, like really down, do we have to kill everything? So those are still also interesting questions that we take into consideration when we are dealing with our software development cycle.
There are best practices that have been developed, and these are constantly changing, improving, being added to. There are groups that are working every day on this, trying to make sure that we have a roadmap of what we need to do and how we need to do it in order to make our projects succeed. And this set of best practices is actually sponsored by the Continuous Delivery Foundation. And this is a special interest group that meets a couple times a month, and they've gotten together and they've outlined a lot of the best practices that they think should be top of mind. Now, keep in mind, these are all like trial and error, hard-fought ideas. These are from groups of people that have been through the fires. They understand, the consequences of not doing things a certain way, and they do their best to describe that in the best detail so that someone new coming into DevOps understands exactly where to start. And they begin in the best place of just understanding the problem. Like we explained at the beginning of the talk, we talked about where we were, this whole idea of developers versus DevOps, this change in culture. These are all things that are necessary in order to be successful at this. Understanding and accepting version control, that seems like such a something to take for granted. I mean, who isn't using version control? But you'd be surprised, every now and then I run into a team that is, storing stuff in files, local file systems, instead of in version control. I see that a lot in like configuration management, for example. I might see infrastructure configuration stored that way as opposed to in version control where it should be. Implementing continuous integration and deployment and testing, they describe all of the environments there. Very interesting to look at. Managing your software supply chain, huge discussion, lots of points there. Configuration management, which I already mentioned. And then this whole idea of reflecting on the end result, measuring yourself, and then making adjustments to improve. Now, one thing that I would add here is just communication. This whole idea of having the DevOps team be in combination with operations. And I'll give a good example of why. I had a project once where we were responsible to containerize an application, get it ready for a cloud-native environment. We did this as developers. We tossed it over the wall. Operations was now responsible to install it and deploy it in the production environment, which, frankly, we didn't even have access to. I think that's fine, but you'd probably need someone on your team with access to that. Now, given that we didn't really have a good communication line with each other, this is what happened. That service sat in production, and those containers would regularly run out of memory. Now, this is something that a developer could address, but we didn't know about it. And operations just wanted reliability, so they wrote a script so that every time those containers went down, they would kick them back. This is not a good situation, and it went on like this for months before somebody decided to, have a talk, make that line of communication with our team, and figure this out. The end result was now the developers were able to understand that the production environment was very different than what we were testing in, and this is just a good example of having that communication flow. Important to know. The CD Foundation really relies on external folks coming in from multiple organizations because everyone is going to have their own perspective, their own use cases, and one person can't guess them all or have any idea of what's in reality going on in the rest of the world. So extremely important to have these groups come together.
And the most important thing for me, I have, when I joined to several of these working groups, I started noticing that engineers from different companies, Google, Netflix, Spotify, we have tons of people from Spotify there, were also joining. So they were telling us the stories, like the battles that they were facing and the concerns they were facing. So some of you may do not know what is happening behind closed doors with these large organizations, but this is an incredible insight into how they're working, and maybe we're facing the same challenges, maybe not in the same scale, but maybe in the same degree or flair. So this is, for me, has been an incredible chance to have these insights to how other teams work. And this is not from the people presenting from these companies telling us all about the great things that they are doing, but they're also presenting or talking about how things sometimes don't go according to plan.
It's a very good segue.
Yes. And why DevOps is so hard? And let me tell you that it's still hard, but because report after report, I show you two reports, which was the Puppet State of Affairs and the DORA report information, and they consistently say, even though this is a push from top to bottom, like the managers really want us to be implementing DevOps because the amount of money that is involved in applying all these methodologies is huge. But we are not there. Like everybody says, we are not there yet. And the problem, it is basically, according, this is to the Puppet State of DevOps report. This is the latest one. They haven't released the 2022, but this has been the trend for the last 4 years. The Puppet report has been up and running for the last 8 years. So half of their time, they have seen that we have the same blockers. So the blockers are two kinds. One is technical, but the biggest one is culture. So whenever you go into DevOps conferences, you will still hear culture, culture, culture. We are not there yet. So some organizations are resistant to change. As developers, we have seen some developers saying, when I started my career, and that was more than 2 decades ago, I still had to talk with fellow developers because I had this radical idea, polyglot programming. And people were saying, no, we're Java developers. I don't want to learn anything else. So I encountered that my industry, the industry that I love, we have this kind of personalities that are really very resistant to change. And when DevOps revolution started coming, they were saying, Ixchel, I'm already learning a language. I'm specialized, like, for example, in performance. I specialize in databases. I specialize in whatever you want. Testing was not well accepted for many, many years. I mean, we knew that the benefits, we knew everything that come with testing, but still people were like, I will do testing when I have the time. And that time never came most of the time. So now that the developer is coming here and the management is telling them, or the project is telling them, you need to learn about observability, monitoring, you have to, like, I don't know, implement meshes, do so many things that it was not in their purview. Define your CI/CD pipelines, program them. People are overwhelmed, and they are refusing the entire methodology. So that's still happening in a broad scale during the industry. The other thing is, if somebody asks me, like, we're going to adopt the microservices architecture pattern, but we don't think that Agile or DevOps is something for us, that would sound really interesting for me. But in the same flair, they are saying we only have monolith applications. So monolith applications do not require us to move this fast because people and our clients expect us to be slow. So that's another misconception, that because we have legacy architecture, maybe this doesn't make so much sense. DevOps engineers, people that define themselves as DevOps engineers, are not very available. And the other reason why I show you those space scale slides were also because I listed the skills, and the skills actually vary from country to country. If you're curious, you can go back and see them. So that's also something that is really interesting. We don't have very clear what a DevOps engineer or a DevOps tasks are in our own teams, in our own industry. So it's a culture problem, it's a perception problem, it's a confusion problem between the architecture and, well, limited or lack of automation. I always say that technology and the machine is the easy part. The human part is the one that is a little bit more difficult.
Definitely. Definitely. This is, and I like to think that you talked a lot about resistance to change, and a lot of that is from fear. We all, we're afraid to do something different because we don't know enough about it. We're not educated about it. So that's what's important about talks like this, and why I'm happy to do this here, is just because, we're getting the word out. There are things that you can do to start down this process and hopefully improve your CI/CD processes, and to get folks involved more in the foundations as well, and to help contribute to some of the resources that we would like to share with you.
Yes. So these are actually the proven solutions that you can take up with yourself. So Melissa was already talking about the best practices aside from the CDF Foundation.
Yeah, there's a number of different special interest groups there that are available. There's one for events, there's one for supply chain security, there's one for ML ops, that one's pretty interesting. And then the one that I chair is called the interoperability group. This one's really interesting to me because there's quite a variety of folks that attend, and the latest success child of this group is the Project CD events. This is a specification to allow for all of these pieces and parts that we have in our CI/CD pipelines to emit events and consume events in a consistent way. This way we can maybe get away from this terrible place we're in where you can't move from one tool to another very easily. So you end up with teams and organizations that have invested quite a lot in a particular tool, and they're stuck. They're stuck now and can't move to anything else because it's just not economical.
Because remember, if you belong to a CD or to a foundation, that means that you're actively trying to implement and define standards. So that means that if you choose a tool that is listed on this foundation, chances are that you are diminishing your chances of vendor locking. So that's also why we are super interested in working with foundations.
And this isn't restricted to just open source projects, for example. I think that's really important. There are vendors, commercial products, people that are in discussing these issues, because everyone has the same goal of being able to integrate with other tools that other people are using. Lots of us have our reasons for choosing the tools we want, and to have a vendor tell us we can't use such and such because they don't communicate, that's kind of silly. We need to be fixing that now.
The other foundation that I wanted to talk to you, because that's close to my heart, this is the one that I work more with, is the Open Source Security Source Foundation. This is also part of the Linux Foundation because the CDF is also the sister foundation of the Linux Foundation. We are also under the Linux Foundation, and we also have working groups, town halls, where we actually inform of all the work that we're doing. There are free training in different platforms, so you can leverage all that. And for example, we are proud. My working group worked really hard for this one. So we have things like that, the concise guide for developing more secure software. And we're proud because we managed to fit everything in one page. So that was a success for us. It's a checklist. So what are the actually things that you have to consider when you are developing more software, open source software, that you want it to be more secure? There are different projects that you can start using, like scorecards or things like that. We also created the concise guide for evaluating open source software. So if you're only consuming software, what are the minimal amount of questions that you have to ask yourself to validate that that particular version or dependency that you're consuming is really important, because 80% of the code out there is open source. Like our code in average will have 80% of code that it's open source. And what is not so great is the average of open source software that we are using is 4 years old. So we are not only using a lot of open source, we are not updating our open source resources. So if we are going to include a new library, open source library, we better have a really good questionnaire. Why are we choosing that particular open source library? Because chances are we're not going to move as fast as we would like to. The final project that I urge you to have a look is Salsa. Who knows Salsa here? Very few hands. So obviously with SolarWinds, Log4j, and everything, supply chain attacks that have increased by 300% in 2021 2022, we also have 3 number digits there for increase of software supply chain attacks. So this is something that is going to be super important for our projects. And we need to understand where are the risks, where are the monsters, how we can mitigate this, what are the small applications, tools, or even checklists. They define checklists. Like, are you thinking about this? Are you thinking about that? So I'm not telling you, go and knock yourself out and install tons of tools, but at least be aware that there are some questions that it's important that you bring back to your development team and know the risks. Mm-hmm. For me, knowing the risks are the most important thing ever.
Yeah, this organization, the group of people that put this together, I mean, it's one thing to say, just make sure everything's secure, but they've actually done a very good definition of what that actually means. And it consists of 4 different levels. So each level you can measure your own pipeline against to be able to communicate consistently with other groups where you need to improve and where you actually stand. And also, I mean, we're so careful now to choose the libraries and dependencies that we know are secure, but what this identifies is there are places in our pipelines where we're passing these dependencies from one step to another. We need to make sure that that is secure as well. So each place where you see this red triangle is a place that you need to take a hard look at your pipelines and make sure that you've got security around there, that you know the provenance of the artifacts that are moving through the system.
And that is it for us. I mean, we didn't show you tools because I am still a consultant at heart. And whenever people ask me about what should we use, and I relish just still answering, it all depends.
Yes. We heard a really good, I heard a really good keynote. I think it was from Nate Shudda. And he said, sometimes you just need to choose one and go. Like, the only way you're going to know the difference between one tool and another is to use it. So just go ahead and make that choice. Make sure you're documenting your experience and utilize your community. We're all here. We can talk to each other and ask questions and decide where our risks and concerns are, what pros and cons of using particular tools are for our projects. I think that's a good place to start. So this, if you please take this QR code. This is just some feedback. It'll bring you directly into a tweet. Let us know what you thought about this talk.
Yes, this is homework, because we were talking about feedback and how important is feedback in your entire software development process. So, please.
Yes, we'll be observing our Twitter feed.
Yes. And if you want to talk to either of us, we are in the JFrog booth and the Speakeasy. We are interviewing fellow speakers at this conference, so we are going to be there all day long. So please come and talk to us. Is there any question?
Any comments? Any horror stories? I'm sure we all have those.
I do. Well, thank you very much.
Yes.